Welcome and good night, everyone. My name is Flavia Bianchi. I'm from Dogpatch Labs, supporter of this virtual meetup. This is the third virtual meetup we've been doing, so I hope you guys enjoy. I just have a few things to say before we start. You can ask a question in the Ask a Question box in the bottom. There are 2 polls going on, so if you guys want to engage and vote, and if you want to talk to the speaker or between you guys networking, you can use the chat box on your right. So feel free to say anything, to talk to the speakers. They are able to see at some point what's going on in the chat box. So feel free to get in touch. And I'm going to just pop my email here in the chat box in case you or someone you know has plans for a meetup or is planning something and just needs some help or some kind of support, because that's what we've been doing so far with Dogpatch. Okay, so without further ado, I'm just gonna pass it on to Richie, who is gonna give us the talk for today. Hope you guys enjoy.
Perfect. Thanks, Flavia. It's really great to be here doing a meetup from the comfort of my kitchen. This is something I've always wanted to do with my life, so life goal accomplished. So tonight we're going to talk about seeing the light with refactoring and testing, and it's kind of a fancy ass title. It was a bit clickbaity, but my goal here was to kind of convey the fact that I think there are better ways to write software, and an awful lot of what us data scientists do is actually writing software. I don't think most of us think about it, because it's like, no, you want to figure out the answer and then provide a report to someone, or provide a dashboard to someone, or provide some kind of information to someone. But most of the time when you start doing it, you're going to end up doing it multiple times, right? So you're going to have to provide the same report, or you need to keep a dashboard updated, or you need to provide some information to someone, or provide a model to someone that they can use to make decisions, or even using that in production. So at that point, you kind of cross the chasm from being a pure data scientist, researchy type person, and you're now supporting production code. The easiest place for this to happen is with SQL queries. Because it's very easy to create SQL tables, and certainly if you're doing any ETL or you're dealing with large data, you're probably going to need to. And then, assuming that people have access to those tables, they're going to start depending on them, at which point you now have customers and consumers and clients, and you need to think in a very different way from just get this model done by Friday so I can go off surfing for the weekend. So what I'm going to talk about today is some tools that I've found useful for actually improving the quality of code and being more confident that your code actually does what it says it does. So what's my background? I'm a psychologist by trade. I have a PhD in psychology, so I did an awful lot of experimental design and thinking deeply about how to measure things with people, which is hard, right? I also like numbers, and as there are very, very few jobs around for psychologists, I ended up as a data scientist. So I haven't really had a class in coding. I've read a lot of books, but I've never had a specific class. I haven't even had that many statistics classes. We focused a lot more on kind of experimental design and data analysis, right? So the real question becomes, why am I even doing this talk? I suppose it's probably because I've been doing this stuff for a long time, almost a decade now, professionally and stuff. And I definitely didn't care about it for the first couple of years of my career. But once people started depending on the numbers I told them, or the results I gave them, or the analysis that I provided to them, I started getting really worried that I was making mistakes and making stupid mistakes. It's okay to make complicated mistakes or different mistakes, but you don't want to make the same mistake over and over again. And when you don't have a repeatable automated process, you're going to do that, right? Because humans are imperfect. So I started looking around for ways I could improve what I was doing and ways I could do better. And I came across kind of a field of a part of software engineering. I was never really that much into software engineering. Always like computer science, but software engineering, not so much. But I actually started looking into how to manage complexity and deal with large amounts of code and make sure that it's actually correct and stuff. And I came across this awesome book, which we'll talk about later, a couple of awesome books, which have provided kind of the framework for this talk. And what I'm actually going to do is I'm going to provide an introduction to these tools. And the tools are automated testing, refactoring, and test-driven development. And so the examples are in OR, and it is a reasonably normal data analytics projects. So hopefully this will be a bit more useful, because there's an awful lot of guides to this kind of stuff in the software engineering literature. And if you go search for examples in Python, you will find an infinitude of them, even more in Java. But like, there's not a lot of examples for doing this for data science. So hopefully this talk can contribute to that in some small way. So refactoring is the art of restructuring the code such that it produces the same results, but in an easier, more maintainable way. And we'll show examples of this throughout the thing. But one of the things, there's this really, really amazing book called Refactoring by Martin Fowler, which I strongly recommend. If you write a lot of code, you should read this book. You will learn a bunch from this book. It's amazing. It's a reference book. You should definitely do it. But the problem with refactoring, the problem with making your code better, right, by restructuring the internal stuff, maybe you have a 100-line function and you want to turn it into 5 20-line functions, or even 25-line functions. If you're not very, very careful, you are going to introduce bugs, and bugs are going to make your life a living hell, especially when you have to talk to your manager and be like, oh, well, I was trying to make the code better, but instead I broke everything and now we've lost $1 million. So testing is definitely a good thing. And this talk is mostly going to be about writing tests and the kind of tests you can do to get you to a place where you can refactor and you can actually build better software. So really this talk is an awful lot about testing. So there's a bunch of types of testing, and they're reasonably well known in the software engineering kind of world, but like they're not as well known in data science, certainly. So there's the level of individual functions. Does my linear model return a linear model? Does my linear model return a set of predictions? Are the predictions always better than the mean? Something like that. Then you have like processes working together, which is integration tests. It's like, can I pull all the data from my database? Can I clean it and process it and then put it into a model, and do I get sensible results? Obviously, you could get anything, but use sensible results. And then for the overall application, functional testing. And a functional testing would be the flow from some big tech company where you push a new model to production, and it changes the ads that you see or the posts that you see in some service, Google or Facebook or whatever. And that would be a functional test. There's an awful lot of space between these 2 points, and it's not really important that you have the correct terminology for them, but I think unit testing is probably the one that gives the most bang for your buck in terms of test-driven development anyway. But integration testing or functional testing are much easier to get started with because you don't need to do as much work. But you're going to get a lot more benefit out of the unit tests if you put in the time to write them. So my code is so awful it can't be tested. This is incredibly normal. This is the natural state of code, is to decay and become worse over time. It's because when you start off writing code, you might not know what you're doing. Maybe you come back to rewrite the code, maybe you don't. Maybe you're in a rush and you just dump it all into a function and it seems to work, so you don't really investigate it anymore. It's Friday afternoon, the beach is calling, and you go home. And after 10 or 15 people have done that for a couple of years, your code is not going to be pretty, and it's going to be very, very difficult to figure out where to start or what it even does. Can I even remove a code? I removed this thing in this file over here, but it broke this other thing that I had no idea about. So this is the normal state of affairs. Don't worry about it. This is something that you can make progress on. So what you really want here is a test that's going to give you relatively high bang for your buck, right? You don't have time to write loads of tests. So what do you test? And the answer is, right, if you have a script, say preparemodeling.org, you test the output, right? So you save your output from a normal run of the test, and then you like fix up this bit of code and you run it again, and you make sure that it actually works. And then you make another small change and you run it again and you make sure that it actually works. And you keep doing that. And if things start breaking, you take smaller and smaller steps. And this is a way that you can like start improving things. You won't get your code to a really good place, but you can get it to a place where it's not incredibly painful to work with and you have a somewhat better understanding of it. So there's a really, really good book which changed my life. I don't know if it's going to change your life. But if you're working with poorly documented or undocumented code that's grown into a monster that nobody really understands, then this book will be very, very helpful. It's worth noting that all the examples are in Java and C++, but I don't think that's particularly important. The kind of the processes and the kind of the concepts that he talks about in the book are effective for everything. There's a bunch of tactical stuff that's like not as relevant when you're writing OR. It is relevant when you're writing Python or doing some other object-oriented programming language, but OR's version of object orientation is so much different. It doesn't really apply. But the principles in the book are really, really good. And so you should definitely get this book. I think you can just get it on archive. Someone sent me an archive link first. It's the kind of book that you want to flick around in, though, so it's possibly worth getting a entry copy. So I really like his definition of legacy code, which is on the screen. Legacy code is code without tests. And I think that's a definition that is easy to get behind, because it like legacy code, it really, I mean, the actual definition is legacy code is code that I didn't write and I would have written differently. But anyway, so the book is super good and I strongly recommend you get it. But throughout this talk, we'll cover a few concepts from the book where I think they're particularly useful for what we're doing in data science. Okay, cool. So this is a characterization test. It is the simplest characterization test you can possibly have, because it's like you save some old data, you read it back in, and then you go call all equal on it. So this is really easy to do, but it's a crutch, right? You don't actually want to be relying on characterization tests, because if you change anything, maybe you decide that you should make sure that your intermediate results are actually outputted and they weren't outputted before. That means you need to rerun your characterization test. So if you want to make any improvements to the code, then these are probably going to break. But if you have this horrible piece of code that's very difficult to deal with, characterization tests are a really good way to get started and make sure you don't break things in the process of making it a little bit better. So super, super useful, but a total crutch that you should not rely on long term. Okay, cool. So there's this concept, and this one doesn't come up as much in this talk, but I think it's a really important concept, so I really did want to put it in somewhere. So it's this notion of seams, and a seam is a place where you can change what code gets run without changing any code. And this is like if you have an OR package, for instance, right? If you rebuild your OR package, or you have a couple of different versions of it, you can change what happens in your code base if you're using that OR package without changing any code in the thing you're actually working on. You can just change the dependencies. And it's not as useful in every situation, but when this is useful, it is such a good approach, because you can run your tests with seam 1, and then you can replace the code and run with seam 2, and it's non-destructive. You don't have to change a huge amount of stuff. It can be really, really high leverage. So it's worth keeping in mind and looking for seams in the code bases that you use. So there's this other concept, which is actually we're going to focus on a lot more in this talk, which is called pinch points. And a pinch point is a place where you can test a lot of functionality with 1 or 2 very simple tests. So in this case, it's going to be a characterization test, right? Where we just output the old as an RDS file or a CSV file, and we just read it back in and call all equal. So super, super useful, well worth thinking about. So first steps is to get the source files you're interested in, run them, and make sure they work. I have do not skip this step in all capitals with 3 exclamation marks, because it is one of the things that has amazed me the most in my professional career is how many people send me scripts that don't actually run. They probably ran on that person's machine, but like these are scripts checked into version control that don't work. And in the best case scenario, it's because they were written 10 years ago, right? And like everybody's moved on and nobody uses it anymore. But in the worst case scenario, it can actually be someone has written a script because you told them they should write a script, but they haven't really made sure, they haven't ever tried to run it themselves and to make sure that it works. And we don't, right? Like a lot of this happens to me a bunch of times when I'm really focused on getting an analysis done. I just abandon all good coding practices and I just do whatever is the quickest, right? And then if you've got to go back to that, you're going to need to spend some time cleaning it up, which is vitally important. You really need to be able to do this. So the example I have, which will come as no surprise to any of you who've seen any of my last 4 or 5 talks is based on the Irish property market data. I do think that over time, the probability of an Irish data scientist doing something with the the property price register tends to 1 over time. Anyway, so I've been working on this for, I mean, a long time, right? But seriously, maybe over the last 18 to 24 months. So I have a lot of stuff that I've done, and it's a total mess, and I have no idea how to do anything with it. And so I want to turn this into an app and actually provide people with predictions of house prices, you know, because just some kind of project to show off, and I think it might be useful. It's probably useful for me, and it might be useful for other people. So my goal here is to take the OR code, then add tests and refactor to make it easier for me to do stuff with this in the future, and not have to fix the same bugs over and over again. Okay, so the first practical step. Again, I'll be sending out this talk in plain text file, and there's a repository which I'll link to at the end of the talk. So you don't need to worry too much about this. But the first thing that we're going to do is we're going to create a package, right? And I'm calling my package PPR because it's the property price register, and it's a nice simple 3-letter acronym. So and then I'm also saying I need these dependencies, and this is actually one of the really good things about OR packages is that they force you to specify all your dependencies and the things that you actually need. And that makes it way more likely that another human being is going to be able to reproduce what you've done, which is normally what we want, right? Okay, so to answer the question I've already started to ask, why a package? Automated dependency management, documenting facilities. Documenting is really, really important. Easy to run tests, and cran check actually just spots a lot of things that are problems and can cause bugs. So you should definitely run, even if you have no intention of submitting your package to CRAN, you should definitely run DevTools check on any of your packages, because it will tell you, it will find bugs. It's found bugs for me. Be warned that releasing on CRAN is not for the faint of heart. But anyway, so the bad thing is more effort, right? Like it's easier to just run a bunch of scripts until you come back to it in 2 years' time. The package in 2 years' time will give you errors if your packages aren't available, as opposed to failing in non-deterministic ways. And then appeasing the mighty gods of check takes time. I mean, if you run some tests and they find problems, then you got to fix the problems, right? So that will take more time. But a package, I think a package is a good approach because it forces you to be a lot more explicit about things, which is really, really important when you want to make sure that things are reproducible and you can actually, you are confident that your work does what you say it does. So we're starting off with 2 scripts, one prepmodeling.org and second featureengineering.org. And the output of both of these scripts is a data frame, ultimately. So we have to run them in order, and they're just a couple of hundred lines of code that is not particularly well organized. But we're going to change that over the course of this talk. So I actually, to be fair, there's actually a step 0, which is to make things a little bit more reproducible. I'm using Conda for OR, and you can install most OR packages through Conda, not all of them, but most of them. So I'm creating an OR Conda environment, and again, this will be in the repository. So ideally, you should all be able to reproduce this relatively easily as long as you have Conda installed on your system. Hopefully, I haven't tested that though, so your mileage may vary, I guess. So the first thing you need to do, assuming that, so my example here, it's worth noting, right, that my example here isn't actually that big. It was more work than I thought it was going to be, certainly, when I agreed to do this talk, but it's not actually that big. In my professional life, I've worked on much bigger code bases and much more complicated things, right? But where you always need to start is get your ground truth. And your ground truth normally means run the code that you have acquired from somewhere that you want to improve. Take some outputs out of it that you can check against your future work to make sure you notice if something has changed. And sometimes those changes will be that you fixed a bug, in which case it's fine, but you should know about those changes. And if you don't know about those changes, you will introduce bugs, and then you may get called away from surfing at the weekend to fix production bugs, which would suck. So refactoring and testing can help you avoid things like that, which would definitely be good. So the first thing I did, right, was I removed everything from my OR environment, and then I sourced the first script, right? And this I ended up having to do this maybe 5 or 6 times because I had to keep adding dependencies, and some things broke and some things were never going to work. I'm not sure why they were in the script in the first place. But then once you've done that, right, you have a CSV with some kind of output. And then when you can make sure, you can figure out what the code is doing and decide what you need to test or what you need to change. But you don't need to change anything right now, and you can keep track and make sure that you're outputting the same information after your changes as before your changes. So the wonderful workhorse of exploring or environments of LS, which will just tell you what's in your script, what you've actually generated, and you can save those objects, right, to make sure that you get everything correctly. So for this particular script, our first one, the prep modeling script, the best pinch point is PPR train and test, right? Because like that's what I'm going to be using for feature engineering. That's what I'm going to be using for my modeling. So I need to make sure that those stay the same. So that's what I'm going to use as my pinch point, right? So the next thing I need to do is to add some data to the package, right? And in this case, it's the private property register. And the reason that I added to the data is it makes it a lot more reproducible. It makes it much easier to test. And it also, again, it means that I need to document somewhere where this sample came from. And as you can see, all I'm doing is creating a 5% sample of the actual PPR data. And the reason it's 5% is because CRAN gives out to you if your data is larger than 5 megabytes. So I basically kept reducing the size of the sample till I got this. And you know, even if you didn't need to sample here, it's probably worth doing because your tests will run a lot quicker if you run them on less data. And assuming that that's a representative sample, you shouldn't really hit any extra bugs. Of course, you will when you scale it up, but ideally you shouldn't. So what we need to do here is we need to run our script with the package data, right? Because so we need to actually make the first change we need to make is to, at the top of our prep modeling script, we need to add in data PPR. So we need to load that particular set of data. And we also need to, as an output, we need to output the preparing for modeling data. So we output that, and then we can run the script again and output the full file. And this was where I had to break my characterization test for the first time. I think I had to break them 3 or 4 times during the preparation of this talk, which illustrates why they're a crutch, right? Like if I had written decent unit tests or tests of invariants that were never going to change, there wouldn't have been any problems here. I wouldn't have needed to rewrite my test. But because I took the really lazy, easy approach of characterization tests, I was able to, I had to do that. I ended up making more work for myself, which was suboptimal. But nonetheless, we run our script and we have the data in our package. So then the first change we make is to write the same data to a new file, call it refactor_refactor.csv or .rds. To be fair, you're probably better off using RDS files, and indeed later on I write some functions to do that. The reason you want to use RDS files is because otherwise you're going to have to do, when you read the file back in, you're going to have to convert numeric to character, factor to character. There's little small differences because CSV is not perfectly mapped to OR data structures. So we rename our output file, and then we run the script again, write the file. So commented out code is kind of the devil. There's nothing worse than looking at a 200-line script and realizing that there's these 75 lines that appear to be mostly repeated, which are commented out in the middle of the script, because it's just scary, you know, because anything could have happened with that commented out code. Anyway, but right now we're making minimal changes to ensure that we can safely update our script. And the reason that we comment out code here is because all we do, like, we just comment out the code, put in our new code, our new function call, or our new data call, whatever that is. And it's really easy to switch back. If we mess something up, we can like switch back, ensure that that actually does pass the test, and then figure out what's going on. So obviously here we have like read Excel, I read the PPR, and I change that to load my package, look at the PPR, and make sure it has the correct names. So one of the things we need to do here is add a test directory to our package, and I'm using test that because it's kind of the default in OR. It's okay, it's not amazing, but it's fine. And then we create some files for test integration, prep modeling, which is basically our old friend output old, output new from earlier. As you can see here, again, the file names and paths don't matter massively. They do all work and stuff, but like essentially you want an expect equal for your old data frame and your new data frame. And that's the easiest test to get started with. We run the script again with the changes we made. Committing your code before you do this and after you do this is always a good idea, because then you can revert back to your last commit and make sure that each time you commit, you should make sure your tests are passing. Or if you can't do that, you need to be very, very careful. So what we do next is we create a small script to run our integration tests, and we call test that test file. There's test that has test file, test package, and test directory functions, which do almost exactly what you would expect. You normally want test package because it's kind of easier to manage your dependencies and packages, but you can just use test file or test directory if you choose not to build a package. So this is I guess this is the philosophy of this testing talk, is like minimum testing for maximum output. Don't get me wrong. The more tests you can write, I think, as long as they're effective tests, testing things that have either broken on you or things that you want your software to be able to do, I think is the more testing, the better. But often we don't have time to spend a long time writing unit tests and deeply understanding our code. We just need to make some changes. So we can improve it a little bit by using a characterization test, and then repeat that. But again, characterization tests are a crutch. They will bite you in the ass over time. They bit me in the ass throughout this talk, but it's the quickest way of getting started with improving your code without breaking everything. So we actually have, like, I spent most of the time doing this talk writing read CSV calls everywhere. And then I realized towards the end of the talk, I was like, why didn't I just write a function? So I'm pretending that I wrote this function at the start of the talk rather than, like, not yesterday, but the day before. So what we're doing here is we're loading in the test data. We store them all in the inst directory because that's where we're running our scripts from. And then we read it in as an RDS file, because that just makes RDS files are guaranteed to work with all equal without you needing to change any of the data types, because the data types get written to the file. So we also need to abstract saving files. We need to write a test. So our context here, context is a thing in test.bat where it'll print out that to the shell. When you're running your test, it'll be like test saving and loading, and then your test will either pass or fail. And it's handy if you have a lot of tests or tests for different things, so you can see where things are actually breaking or which tests are taking a long time to run. So again, all we do here is we say that if we load the PPR data file and then we save it and then we load it as test data, then it should be equal to itself, which it should be, but we could easily have a bug in save or load test data that would prove to us that was not the case. So this is nice because it tests what we actually want, right? Like, it's the invariant we care about. So if you can test the invariant you care about, then you're going to have a much happier time in general. So we also need to write a function to make the test pass. You'll note here that I have a test, and then afterwards I have the function. And that is essentially test-driven development. First, you write a test for what you want the function to be able to do, and then you write the function. And the reason this is good, right? It sounds kind of crazy. Like, I heard about it years ago, and I was like, why would I ever want to do that? It just makes no sense. However, once you start doing it, you realize that it makes things a lot better, because you have to specify what you want your code to be able to do to write the test, write the failing test, and then you know when it does it, right? And you can obviously write test-driven development. You can say, does not return NA for something, which is an easy test to pass, but it's useful to get started. So here we're saving the test data. Again, we're saving as RDS, and everything's in inst, so we don't need to worry about our base path. So we have our test data. So the next thing we do, we've reviewed our scripts, and you can look at these in the repository. I thought about putting it in, but the scripts are so long that it doesn't really work in terms of like something to present. But I do encourage you to check out the repository and look at what the scripts looks like at the start of the process. So we have a couple of functions in there. We have like normalize names, fixed price, and generate bootstrap results. We move those functions to a file into our package. Then we change our script to load the functions to the file. So we have a package with code in it, a package that actually does something, which is nice, right? And then we run our integration test again. And if something has broken here, we go back and we remove everything, right? And then we like add the first function and make sure it works. Run the integration test, make sure it passes. Then we have the second function, run the integration test, make sure it passes. Then we run the third function, run the integration test, make sure it passes. And if you keep taking smaller and smaller steps, you can normally localize where the bug or the problem is, which is basically what you want, right? Like it reduces, the joy of this stuff is that it reduces your debugging time, which is, as I'm sure all of you know, is what most of us spend all of our time doing. Certainly when I'm working with code or data, I'm mostly debugging or trying to figure out why something is wrong. Anyway, so next thing we're going to do is we're going to write some tests. So this test is actually a test for a function that isn't really necessary for this talk because I'm just handling, I put the data I wanted into my package, but I actually wrote a test for load data because I know that I want to dump all the PPR data to a database or something because I just think it's a better storage for it, and it's just going to make it easier to grab samples and to model it and stuff. And maybe, yeah, I just think it's a really good idea. So I'm abstracting the loading of my data behind this function so that when my data loading logic changes, not if, when, I don't need to change very much. I don't need to go through my code and find all the read CSV calls, right? I just need to change one simple function, load data, for which I have a test. So again, this is a really simple test. Load data returns a tibble. It actually returns, there's a vector of length 3 in it, like it's tibble df, source, tibble df, source tibble, and data frame. But we just need to check that it returns this tibble because all tibbles have that in place 1. But this function doesn't actually exist, right? And it's, when I do create this function, it's a pretty crummy function. You can see that, like, number 1, it actually only takes an Excel path, and number 2, it only takes a specific Excel path, which like is terrible, right? But I know I'm going to be changing this, so it's okay. And I've abstracted it away. Someone just needs to look at load data and say, oh, that loads data. I just need to look for load data calls if I want to find out where data gets added to the project. That, like, the benefit here is the naming more so than the abstraction. So it does make sense for me. But again, this is the kind of stuff that wouldn't make sense in lots of other contexts. So the next thing I do is I write a test for my normalize names function. So normalize names, essentially what it does is it replaces spaces with underscores and gets rid of capitalization and gets rid of like things that aren't ASCII that annoy me. So you can see what the finish names are supposed to look like there on the screen. And then we run a test and expect equal finish names to names, normalize names, whatever our data was, right? So this is kind of a crummy test. What I should do is like generate random strings for names and then assert that they only contain lowercase and underscore, because that's what the function actually does, right? So this is a terrible test, but it was quick, it was easy, and it makes sure that things don't break without me noticing. So the next thing we needed to do was add a test for fixed price. So what fixed price actually does is it takes, you know, the way Excel and people who use Excel love commas in numbers, which is great for display, right? If like, it's much easier to read 3 million with commas than it is, you know, 3 6 zeros without commas, right? I have to count them if there's no commas there. But I don't actually want that in my code because OR thinks that's a character or a factor, which is not what I want, right? So I have to write a test to make sure that fixed price actually works. The problem with that, and I guess it's not really a problem, right? It's I've spotted a bug in fixed price. So can anyone spot the bug? this is weird because full disclosure, I can't actually look at the Crowdcast interface because otherwise my presentation will disappear, and we'll all see that infinity mirrors thing. So I don't know if anyone can spot the bug. It took me quite a long time to spot that bug. So I have a test case for the bug, which actually means that it's much easier to fix, right? And the benefit here is not this particular test. It's making sure that I don't introduce this bug in again, which I had done a couple of times. So I'm happy that this test is there. So because obviously you need dots are valid in numbers. Commas aren't valid in numbers, but dots are valid in numbers because they're a decimal point, right? So we have a failing test, so we can fix the code and make sure that the code actually works. So all we need to do is remove our little dot in our gsub call, and it all just works. Okay, so refactoring is all about, like, sometimes it's bringing code together, but most of the time it's breaking out the components of the code and figuring out what does this thing actually do, and then either giving the variable an informative name, not like ppr3, which mutates ppr2. Those are not informative names. Those are not the kind of names you should use. Those are stupid names. They worked for me when I was the only person working in this code base, but they're not the kind of names that I would ever use for something that I expected other people to read. Like I'd name it. I don't actually know what I'd name it, but I'd name it something different. But anyway, we have this code here, ppr2, which first it accounts for the bug in fixed price because I hadn't realized that I was introducing that bug myself back in the day. And then it determines if the price is big or not big, right? Like, and the reason I did this was because there's a bunch of sales in the PPR, which are like, you know, normally once they go above 1 million or 2 million, I really don't care. I'm never going to buy a house for over 2 million. I mean, maybe someday, but certainly not anytime in the near future. So it's irrelevant to me. So I wanted to make it easier to filter out those things. So we can turn this into a function. So we call the function mark values as large works. And here's our function, mark values as large, test df input, and large is 1 million, and test df output, right? So note that we haven't actually written that function here. Right now, all we have is this code here. Now, so we write the function, by which I mean copy the code from the function into copy the code from the script into a function, and add some tidyverse magic to allow you to use non-standard evaluation, which is what we're doing in the original code. And we just add the double bang to get large spliced into the mutate call, and we return the same thing. Note that I haven't actually changed the internal name here. I probably should have, but you don't need to do that. It's generally clearer, so if you've time, it's a good idea to, but it's obviously not essential. So this is the extract function refactoring, because we've taken a bunch of code and we've pulled out a small modularized component of it, and we've called it a function. It gives mark values as large. That's mark values as large, right? Like, is a lot more descriptive than this, or at least to me. Maybe it isn't to you. Okay, so sometimes we actually want the function to be inlined, where we want to take our mark values as large function, and we're like, hey, I'm actually doing a bunch of mutate calls around there. There's no point in naming them all separately, doing them all separately, and then merge them all into one mutate function. So in that case, you pull you do the reverse, right? You pull everything from the dplyr mutate call out, dump it into wherever your script is, and then put it together with other things. So it's refactoring in the sense you can extract functions into separate components, but sometimes you want to bring them together either because they're really, really simple, or because you want to split the code up differently. So the next thing we need to do, and I'm sure as all practical data analysts know, the best thing you could do with your response variable is log it. If you can't log it, you might want to square root it. That's not actually true, but a lot of the time it helps, right? Because if you have price data is a good example, because it's unbounded in one direction, right? And it's positive. So logs are really useful for data like that. So what I did was I logged price, and my performance of my model immediately went up. So that was great. So I wanted to keep it. Like, the question is, does this need to be a function? Like, it probably doesn't, but it might be more useful if it was. So We're also testing the implementation of log, which is not something we care about right now, but it would be it's good to know if log price is not less than price. So for instance, this test would fail if we ended up with some negative prices in there, which is something we want to happen, because if we end up with random incorrect data in going into our model, then things are going to go horribly wrong. So you want that, right? So we just log the column. Again, I haven't actually written this function at this point. I've given it a name and an API, but I haven't actually written it. So this is one of the really good things about test-driven development, in the sense that you have to think about how you're going to use the function before you actually write the function. Because I'm sure we've all had the experience where you end up writing this function that does something important, but it has like 7 or 8 parameters, and like some of them are conditionally important depending on the values of other of them. And like that stuff is harder to get away, harder to end up with if you're doing test-driven development, because it will be much easier to test that stuff in isolation. So you end up turning it into an amalgamation of several smaller functions, which is it depends on what you're looking for, but I find that to be a better design. But again, it provides documentation and a usability check for your functions. So yeah, we need to call the enquo and bang bang too, because people love non-standard evaluation these days. But you know, it's something that's useful to do. But again, the function itself is really easy, but it's important that we have the test so we know we're not breaking anything. And it's worth noting, right, that every time I say run the test or write a unit test, I'm also running the integration tests. So when things break, I become aware of it very, very quickly. And then I'm able to fix it at the time, as opposed to writing a bunch of brilliant code for 45 minutes, figuring out some amazing stuff, and then realize your output isn't consistent with what it's supposed to be, and you've had a bug somewhere and you spent days looking for that bug, which has happened to me, right? So this is why I like this kind of approach. So the next thing we need to do is handle this field, not full market price. It's just a stupid name for a field that doesn't need that negative. So all I do is change it to is full market price, and then get rid of not full market price. It's like, you don't really need to turn this into a function, but for the purposes of this, it's probably worth an example. So again, write a test. Not a great test, but we're just making sure that we always have an is full market price column after we've run the function, which is invert field. So again, if we were using this for this wouldn't work for anything different, any other names, but it's just putting some gnarly logic behind a function so you can identify where the problem is, right? So if you know that your problem isn't in that function, then you don't need to pay any attention to it. You can extract over it and just pretend it's a black box. So this test fails. I run it because I haven't written the function yet. And then here we go. We take the invert field. I did change the name after, it was called fix field names first. So I did change the name. I was like, invert field is actually more descriptive of what it does. And then, again, this is not a great function, but once we have tests, we're in a position where we can refactor a lot more aggressively. We can actually change more things, and we're not wedded to bit for bit output compatibility with all the data, because we may find bugs. And if you're doing this in any large project, you will 100% find some bugs. The only problem is those bugs are probably dependencies for someone now, which is an interesting experience. Okay, so I've actually, this logic for fixing description of property has 8, 9 different pipes full of if-elses and nested if-elses, because the description of property field was broken. It's just a horrible field. So I wrap it all up into a function so I can pretend that it doesn't happen and that my life is normal. So we just dump it all into a function. So it goes on for about 30 more lines, but you'll see if else change into if else, and it's all like that, right? The only thing I really did that makes it a bit better was that I changed the names here. I fix new and remove Irish, or fix greater than, fix shorter than, stuff like that. The names are somewhat descriptive of what the function is actually doing, whereas before they were PPRs 5 through 10 or something. So It's super painful to write a new unit test for this. So all we're going to do is we're just going to write a characterization test for it. We'll just make sure that it outputs the same data, and then we don't need to worry about the gnarly logic for the time being until we need to change the property description logic, at which point we're going to need to write more tests. But it's a trade-off, right? Okay, so we essentially just add a write CSV call or a save test data call or save RDS. Just put it out in some way, and then you write the test to make sure it actually works. So at this point, we've done a lot of our data cleaning, right? So the next section is about handling the test and train set, splitting our data to make sure that we can fit a model and we don't overfit. So the first thing that we notice here is that we end up, this is my test, right? But I end up having to write most of the functions that I actually need for the data into the test, which is good, right? Because again, this test will pull up things that change in any of these functions: normalize names, fixed price, mark values as large, log column, invert field, and fixed property description. And we test that it returns a list. So I'm going to start with a simple test, and I'll make them a bit more specific as time goes on. So this is the result. And this is clearly a joke, right? Because it doesn't actually work, right? The function doesn't actually work, but it's actually kind of a style of test-driven development, right? And it's called red-green refactor. So the idea is that when your tests fail, you get a red light, and when your test pass, you get a green light. So the idea is, certainly in test-driven development, is you would write a stupid function like this that just returns a list, right? And then you'd write more specific functions to guide what the API should look like and to make sure that you're actually returning something useful. But the idea is red-green refactor. So you should never refactor when all of your tests aren't passing. And you should aim to get to green as quickly as possible, by which I mean that all of your tests have passed, so that you can refactor. Which is kind of like, there's a book, Test-Driven Development by Example, that is really, really good. It's really short and it's really, really good. And it kind of provides the philosophy behind this much better than I could do. So what we actually do is we dump all the code into a function. Interestingly enough, did you know that if you call setSeed in the global environment versus the environment of a function versus the environment of a package, things change. SetSeed isn't quite as reproducible as you might believe. I didn't know that until maybe a year ago, and I'd forgotten it, and I remembered it again when I was actually writing this function. But so generally, this function is kind of long because it splits data into three. It splits it into, first it does test and train, right? You can see that 70% in train, and then it splits the test into two 15% size samples, and then writes the validation set to disk and removes it, right? So you always have a validation set, it's always on disk, and you're never at risk of using that such that you'd mess up your ability to measure the outcome at the very end. It's quite a long function, but again, it's a couple of calls to caret. The only reason this function doesn't fit on the screen is because if I wrote it, you have to indent your code very much vertically to make it fit in a presentation. So unfortunately, you can't see it. But again, I provide a link to the repository at the end, so you can see all of this code should you actually be interested. And again, note that this is a terrible function. It has one parameter, which is your GF. It doesn't allow you to set P. It doesn't allow you to say what variable it is. It makes loads and loads of assumptions, but it does make it easier to test this whole bunch of logic and to make sure that it actually does what you think it's going to do. So we add more tests. So we expect it to have train and test, because that's what we return. We return a list with a train data frame and a test data frame, or a tibble rather. So we test that it has train and test. And then we expect that the train part is a table GF, is a tibble. And we also write more tests. So it returns a test tibble. And the final test, which is an important one, right? That train has less rows than input. Because if it's a sample, then it should always be smaller than the input. And again, that last test is a good one because it's like the invariant that you want, right? There's never a case where your training set if you're doing cross-validation, is going to be the same size as your input set. It will always be less. So you'll note that we've written a bunch more tests for split data. And the reason for that is that split data is more important. You should concentrate your testing where it's going to make a big difference, where you're not sure about the logic, or where if it went wrong, then things are going to be really, really bad. So yeah, yet more tests. So we can now move on to the next script. So we add another write TSV or save word DS call to our original function, and then we write that as old, and then we update so that we can write another integration test, so that old and new are equal to each other. To be fair, really, I should be abstracting over this old and new stuff and like actually generating this function. But this was for a presentation, so I erred on the side of teaching people stuff rather than being abstracting. That's what I'm going to tell myself anyway. Okay, so the first step you need to do when you're doing this with any kind of script or any kind of application, whatever, you need to figure out what the script does, right? So you need to read through it, take notes, and see what you actually need to make the script work, or to get what you need out of it, right? So what it does, it takes the data from the previous script, fits a simple model on the original data, loads in the geocoded register, which is obviously a different set of data, loads in the geocoded register plus the Pobble data, which is really, really predictive for property prices, fits a PCA, fits a linear model, loads vtreat. Vtreat is a package that allows you to pre-process data really, really effectively by hand, by kind of in an automated fashion. It does a bunch of transformations and you can control it, obviously, but it outputs a data frame that you can just toss at caret train or linear model or whatever you want, and it should be fine. Like it won't have any missing values, and it'll like handle the problems in your data much more effectively than your handwritten code would. So vtreat is cool. So I've analyzed what the script does, but really most of the stuff I don't care about. All I actually need to make sure that I can input into the next step of my process. In this case, there isn't really a next step to my process, but in any real application there would be. So I'll ignore the PCA and the simple models for now, and I'll just focus on getting vtreat work. So the trouble here that I didn't realize till quite late was that because I have different sets of data, I actually need to read in, create those and add those to my package again. But again, this is useful because it means that I have data to test my functions on, and it's just much easier. So again, take a 5% sample of the geocoded PPR data. Again, note the terrible, terrible names here. You know, I would probably pay more attention to this if it wasn't an internal project. But again, naming is super, super important. So anytime you need to think about what some code does, you should probably give it a better name. Anyway, so we create more data sets, do the same for the Pobble data. Just as an FYI, you actually need to run, like you can generate these files that will generate your package data, but you actually need to run them into an interactive OR process. Otherwise, it just doesn't work, which is super weird, but that's just the way of it. So you should also document your data sets. I didn't document my data sets, but in general, if you have any data in a package, you need to document it. And if you're submitting it to CRAN, your package will not be allowed on CRAN unless you document all the exportable objects. So you should definitely do that. So again, we need to update the integration test, and note that sampling will break your integration test because they're just characterization tests. They're just making sure old is equal to new. So if you change your sampling or set seed changes, which happen to me a bunch of times because of the functions and stuff, you're going to break your integration tests. You may need to run them again. So it's worth paying careful attention to anywhere where sampling could be happening or seed could be getting set, which is a surprisingly large amount of places in OR. So that's definitely something you should be aware of when you're doing this on your own projects, because it will mess up your day. It certainly messed up my day. So here we have the only function that I really needed out of the second script, because there wasn't a whole lot that was necessary for what my purposes in there. So I generate model matrix. It doesn't really generate a model matrix, but it's an equivalent kind of structure in that you can just pass it into a statistical model and nothing will break. It can, when you coerce it to as matrix, it will be totally fine. So for vtreat, you actually need an independent sample to build your. Oh God, there's a bug in that. Damn it. Anyway, so for vtreat, you need an independent sample to calibrate and to encode your variables, because it uses your outcome to encode the variables, right? So here we create a calibration set with 5% sample, and then we anti-join that to create our training set. This is the first time I've ever actually used dplyr anti-join, so I was like, oh, cool, got to use a new join. But it basically just takes the calibration set out of your data frame, and then you have two different data sets, one of which is used for calibration, and the other one which just has the processing learned from the calibration set applied to it. And then it returns the result. So this is worth calling out again, because sampling is the devil when you're using integration tests and characterization tests and stuff, which is why they're a crutch, really, because it just causes a lot of problems. But they're a very, very useful crutch. Just like if you've had your hip replaced, you are going to love your crutch. You don't want to have a crutch forever, but it gets you to a place where you don't need the crutch anymore. So it's a good crutch. So finally, kind of for the last kind of thing to talk about refactoring, I focus very much here on kind of like, I don't know what you'd call it, like practical refactoring, in the sense that put things that I need done into functions, split data, normalize names, these particular tasks, right? But like when I was looking over the second script, I realized that there was lots of stuff that I did in both of the scripts that I should probably have created functions for, right? So I have PPR pobble, end distinct, as data frame, run into column, and array. So essentially, it counts the distinct values in each column of the input and returns that as a tibble, I think, and arranges it such that the columns with the most distinct values are at the top. Now, this is important because obviously, if you have like 10,000 rows and 10,000 distinct values, you ain't going to be putting that into a model and getting anything effective out of it. Or it's very unlikely. Whereas if you have, if you only have 100, you can probably put each level of your factor in. But if you have 10,000 levels of a factor, you definitely need to aggregate it in some way. So that's why I tend to write code like this. But the code is unique, right? But the pattern's common. So essentially, I turn that into a function. And I actually make it, I have since used this function in a different analysis. I'm really happy with writing this function, so it actually turned out quite well. And it's also like, this is more useful because it doesn't make assumptions. It's reusable, and it's also a lot more amenable to testing. As always, we start with a characterization test where we just copy the data out and make sure it produces the same data. So again, I'm doing stuff like this, get max and min, like figure out what the max and min for various variables is. Again, I'm doing this because I want to make sure the scales aren't completely off, because again, that'll break an awful lot of your models, certainly your linear models and stuff, if it's not scaled normally itself. So I turn that into the same function, where note that there's weird stuff, because I end up, supply returns strange things sometimes. So I ended up having to coerce it to tibble and then using unnest and bring it out properly. It was super annoying because the min and the max. I think there's definitely a more elegant way to do this, but this worked, and I was able to put it into a function, and I can use it. So value counts. I don't know if anyone knows about the value counts method in Pandas and Pandas data frame, and I was like, wow, this is actually useful, and Or doesn't seem to have it, because I end up writing code like below, where I'm taking a table and I'm changing it to a data frame, and then I'm arranging it based on the frequency of the values, right? Again, this is to make sure that I can use factors in models, or whether or not I need to treat them. To be fair, vtreat does a lot of this stuff for me, but it's always worth knowing how to do it yourself. So I changed it into value counts. Note that, again, because I want to use non-standard evaluation in the call, but we're not using dplyr, we actually need to use the base way of evaluating bare names, which is eval substitute call in the environment of the data frame, and run table on that, because that basically passes in df $call to table, and then make sure that you always count NAs and return it in descending order of frequency. So, and finally, count proportion missing, which is kind of does exactly what it says in the 10. Again, you can see that like a good name is half the battle, because if you see like result equals count proportion missing data frame, you kind of know what you're going to get out of it, right? Whereas if you just see the code inside the supply df function x, I mean, you can read it, but it takes a lot more cognitive load. So it's anything you can do to reduce the cognitive load on yourself is going to be super helpful. So I don't actually need these functions. I went a bit mad and started refactoring all of the things, to be honest. Probably not what I should have been doing when I was trying to get everything working for this presentation. But anyway, but I can just add the data from the originals for test data. And these last few functions are probably the most useful thing in my package. They're certainly the only thing that I'm going to reuse in multiple different projects, because the other stuff is very, very specific to the property price project. So they do need some tests though. So characterization tests, and it fails, make sure your tests fail when they're supposed to. If your test doesn't fail when it's supposed to, that's really, really bad. Again, same thing. So to conclude, well, okay, it's been an hour. It's very weird because I can't hear anyone, and I don't really know what other people think of it, and I'm sitting at home. Anyway, so to conclude, automated testing is the ball. You should be doing testing. Go home, go into work tomorrow, write 1 or 2 tests that will allow you to make sure things don't break. Even if it's just tests on your SQL table to make sure, they have greater than 0 rows, or that your groups are the right size and stuff like that. Anything you can do that you can automate in terms of testing will pay massive benefits, because you don't need to remember all the subtleties all the time. You can outsource the consideration of the subtleties to your tests, and your tests will tell you if you fuck up, when you fuck up, because we all fuck up. So automated testing is not only really useful in and of itself, it's a foundation for refactoring, or like changing around your code such that it maps to the problem model you're trying to solve a bit better. So I think this talk has demonstrated how to get started. I really haven't gone into that much detail on any of the things here. I do really recommend, there's a bunch of books linked here at the end. They don't look like links, but they are links. All these things are links. So automated testing is super useful. You should do it. Refactoring is also the book. Just get that book. It's a really well-written book, and it's amazingly useful. It does use JavaScript for examples, but that's not really a big deal. And then once you have tests, test-driven development it's a really pleasant way to develop new functionality. Like it's just kind of nice, and like you feel like when your test passed, you feel, this is all fine. And then when your test break, you're like, oh, something broke, but you know exactly where it broke, right? Because your tests will break in a specific way based on what you've done. And if you don't understand where it broke, you debug, and then you write a test to catch that breakage, such that you will know in the future. And it just it does require a bit of discipline and upfront time to put in a bunch of unit tests specifically are really useful here. But it is well worth it. It really just does make your life a lot better. So there's another repository on GitHub which has a simpler example of refactoring, again for the property price data, but some Python code. And there's a poker simulation in Python, which I developed for using TDD, and the repository for the talk is here. The repository hasn't been updated right now because currently everything broke. My characterization test broke again, so I need to fix that before I push that to GitHub. But I will do that in the next day or two, and then it should all just work. So if you'd like to go deeper into this stuff, there's the Martin Fowler Refactoring book, the second edition, which is much newer. It is really, really good. Strongly recommend it. Test-driven development by example by Kent Beck. It's actually kind of hilarious, really short, and really, really useful. So it's like if you only read one of the books on this page, read Test-driven development by example. And then if you are working with large code bases that you are not responsible for, you owe it to yourself to read Working with Legacy Code, because working effectively with legacy code, because it really it frames the problem in such a set of good ways that it makes it much easier to deal with the madness. So yeah, so I haven't covered that much about any of them, but hopefully I've given an introduction to them, and you now know what they are, and you can talk intelligently when your programmer friends talk to you about refactoring and test-driven development. Cool. That's it, I guess. Okay, hang on.
Can you hear me?
Yes.
Oh, okay.
Okay.
Turn on my video. There we go.
Okay, cool. Oh, wow. Oh, yeah, you
A
told
lot of them
your...
are me. A lot of them are me. We've had a couple. We actually have a quick shout out to Alex if he's still on the chat. We have a viewer from overseas who isn't in Ireland.
Oh, wow.
Alex is watching in from Greece. So
Cool.
shout out to Alex. Thanks for joining us. Because we were just saying one of the nice things about having virtual events is that basically people from overseas can join.
Yeah.
Great.
Yeah. No, this
and
it's
all
definitely
of these are
recorded
recorded as well, because I'm going to go back through all of this. And so we've had a couple of comments. Not very many people have said much in the questions. Most of them are there of mine. One very quick one actually I wanted to ask you was, so by all means, I'm going to keep an eye. We'll keep an eye on the chat for the bit, we'll have another 5 or 10 minutes because I've got a couple of questions I want to ask. But yeah, naturally. I was sitting on my hands here going, I could just
it's so weird not getting
I thought when I had it, I might say this again for future ones, is that I'm going to try and recommend people have 2 screens because it's really good to have that feedback off the chat, which I really liked, because I've done a few where you don't have the feedback, and it's nice to have a second screen somehow. There is a couple of apps now that allow you to actually use your like a tablet as a second screen.
Oh yeah,
that's quite handy, and it just mounts as it's like a dual monitor, as well as obviously you can buy for a couple £100 you can get secondary monitors for laptops.
Oh yeah, well I have a monitor. I just didn't think about it, but they're sending me out one for work, so I'll just do that probably if I'm doing it in the future. So
anyway, the first, and we're going to keep an eye in the thing. I should say there's a guy called Jean Mangi. I'm sorry if I've butchered your name. He's made a couple of comments, so I'll probably be in touch with you about maybe a future talk, because you seem to know a lot of what you're talking about. You mentioned using to control the workflow, and Drake is one of those things. Like I got into Docker instead, but Drake is something to kind of clean your environment. Anyway, before that, I have one really quick R question: is what's the difference between? I saw you were using use this with use package. What's the difference between it and library and the whole import depends thing?
So back in the dawn of time, by which I mean like 2 years ago, I learned DevTools like, I don't know, 2015 or something. But then Hadley got too much funding and RStudio had too much money, so they hired a load of people, and then they decided to break out DevTools into like 12 different flipping packages.
Okay, that's good. Session info is the one I use.
Yeah, and use this really handy one of those packages.
Right.
Yeah, so it's just basically DevTools use package. It's adding a dependency to your package.
Okay, so it's package though rather than like workbook?
Yeah, package.
So it's not a replacement for library?
No, not a replacement for library.
And what about then, so does it automatically do the thing like puts the entry into import and depends?
It does, yeah.
Because they used to do that as part of the Roxygen stuff.
Yeah, it technically...
changed that, have they?
No, that's where namespace and description get written. Like...
Yeah. Okay.
Who knows?
It's very inside our stuff.
Inside baseball,
So the next one I put up was, and this is something you and I have had a private conversation, but it's worth having here, is that I really want to use testing, but I often struggle figuring out how to alter the workflow to allow for it. So especially in research style work that lends itself to instant notebooks. So how do you deal with this problem? So like to give an example, and this prompts the second one, which we can get to after, is if I'm writing like a flow and it's generally, notebook or table in, table out, or out, or table in, I just find that very hard to write tests for. How, but before I forget, Martin Fowler is also a big
board gamer. I see.
Yeah, I said that. Yeah, he's on. He's on Heavy Cardboard quite a bit. He comes across a very, very nice fella. But they were all saying, because none of them are computer people at all, so they have no idea they're sitting at the table with a guy who's a bit of a rock star.
He's kind of a legend. Yeah.
He's a bit like he's Hadley famous, as they call it.
He is. He's more famous than Hadley.
Definitely.
Way more.
But that phenomenon, whereas everyone thinks he's just the English dude. Apparently talks about computers from time to time. But yeah, so how would you go about? Because one of the things I would love to start implementing testing. It's something I really want to do because this has kind of bite me a couple of times in the last few weeks where things change or break, and you're like, oh man, I really should have a test.
Yeah.
But I'm not quite sure how to, because quite often I'm dealing with like big tables, and it's often ETL style work in a lot of cases. And even if you're not actually doing something in production, it's still effectively ETL work. So how do you go about that, especially for like workbooks?
Well, you see, like I hate notebooks. Notebooks are the devil. I do use org mode, right? Like, which is kind of a notebook, but like notebooks, the Python notebooks, I've had so many weird state bugs with them that I try to avoid them as much as possible now.
Yeah.
But I like it's more.
Don't forget, our Markdown's more like org mode in that it's an input.
It's an input file and output file.
Because I actually talked about that in the last talk. That we actually had that was a topic that, like, how to use that kind of stuff. So I don't like Jupyter either because of the mixture of input and output.
Yeah,
it became very hard to use under source control.
Oh, it's impossible. Yeah.
Well, you can, but you have to create like pre-commit hooks and stuff. It gets messy. But like I said, I love workbooks because they're essentially your lab notebook when you're not necessarily writing code. So how do you kind of? I'd love to square that circle, but I haven't figured out how to.
So what I tend to do, like, and this is my flow, right? Because I use org mode, right? So like, I will have, like, when I was writing this presentation, for example, right? I pull out a bit of code and I put it in for the presentation, right? And then I also, at the bottom of my file, I have this thing that doesn't get exported, where I actually I put the code in with all the documentation, generate it for my package, right? Like, so then it's like, I kind of separate out the stuff that's like, that's reproducible or that's I'm going to need again from the stuff that I don't, right? So it's like, so what I would tend to do is like, so I have, you have this ETL transform, right? And you like, like you encode that in a function. It's like my mark values is large or fixed property description, right? And then you can test that function. So that's probably the easiest thing to do. You can do, like, again, while you're doing this, you should use characterization tests to make sure you don't break things as you're changing into functions, right? But like, I'd probably look at 2 or 3 of the things you're doing and then see what the common patterns are, and then start being like, oh, that looks like a function, and then test those functions. And over time, you just get better at like figuring that stuff out.
It's funny. I actually went there. I used to write everything as a function. And then as I slowly kind of realized the power of workbooks, I've gone into not using functions. Well, I do use them, but not nearly the way I used to before. But now I'm actually wondering, can I move back slightly to use them a bit?
Yeah, it's a balance, right? Like, because
when you're doing readable is the problem. When you have kind of, I find if you're like, how do I phrase it? If you're creating a function and then immediately using it and then not really using it again,
that's a waste.
Workbook becomes a bit unreadable as well. It actually hurts readability.
So for that kind of stuff, I'd normally either put the functions in a separate file or at the top of the file. Like, because I just put them all at the top and then I can just like, then it shortens the business logic a bit, so then it's easier to pick them out. It's just, I need to understand this function and stuff. Like, that doesn't solve it if your function is doing 3 different things and creating a link to a database. Like, still not going to save you, right? But like, it makes it a little bit more manageable. But it's more like, I don't do this stuff when I'm doing as researchy stuff. When I'm analyzing data, I won't do this straight off the bat. But it's like, once I start pulling it all together into a script or whatever, and I'm like, this is kind of complicated, then I'm like, okay, I probably need to test here.
Actually, that's a good point, because it's very, like, to get to your point, I mean, I have in the past had to put stuff in the crawl job, but I'm usually at the very start of the process, and typically, certainly in the consulting days, that's kind of where it would stop. That's a bit less so now on the product side with it. And I'm also thinking, as you talk about like converting all our Markdown documents, not converting them, but now that that's almost like my spec, I can probably start going back and refactoring them. For that work process.
What I would do is I'd like tangle them out, right? So do they use that word in the remark where you just take out the code, right?
Oh yeah,
take out the code.
JSR has Perl, I think it's called.
URL.
So, and it just literally turns it into an R script.
Yeah, so that's where I generated the 2 scripts I used in the talk. They were actually scripts for my data science bootcamp that I did like 6 months ago. So it's actually not the crazy bad code that I wrote 2 years ago. But yeah, like, so I would generate that and then put that into create a package, put it into inst, and then follow the same process where you like slowly turn it into functions.
So just to see, I've seen there's a guy, Damien, he said, yeah, seems it's more like production code development as opposed to the sort of prototyping or exploratory analysis that you would do in Jupyter, etc. And that's true, but there is a caveat there in that, and this is where I'm starting to struggle here, is that I find that it's very easy to make mistakes in your code in that point, and they can have very significant downstream consequences.
Oh, yeah.
And this is why I'm trying to figure out ways to start testing earlier than I have been. You know what I mean?
I mean, I do like test-driven development. Because I agreed to do this talk, right? So I basically just been doing this refactoring talk. But like, what I'd like to do is try test-driven development for an analytics project and see how that works. I don't know if it's going to work. Like, so am I. But I'd like to try it because if I could get that to work, that's what I'm going to do forevermore.
I could see it working for a package with a well-defined. The problem is an awful lot of packages that you're going to be doing are like fitting models and stuff. That's just really brittle when it comes to testing. It's very, very brittle.
Yeah,
I was mentioned. It got mentioned there in the like sample changed, for example, in R4. Like they changed how they do sample, so all of that would have broken. You know?
No, because they always retain the old version. But yeah, if you didn't specify that argument, whatever the method argument is.
Oh,
or
right.
Was it the RNG they changed? Because I think that's the set seed bug.
There's a bunch of them.
They fixed it. Myself and Martin found. So I was telling someone to functionalize all their code back in LexisNexis, and then they found the set seed bug where it actually returns a different sample if you do it in a function as opposed to doing it in a global namespace.
You should never set a seed inside a function.
I know.
You invite at the very start, and then you don't.
I know. But like, what do you do when you've got characterization tests and people have set seed in multiple different places? Like, it's
What exactly? Because I had a couple of issues, and I'm conscious of the time, so we don't have much longer. But what's a characterization test again? Exactly?
So that's where you're like, my old data frame is equal to my new data frame. So like, I output what I expect to get out of my script, and then every time I make a change, I rerun the script and test to make sure those two things are the same. So it's like, it's the lazy man's approach to testing. Like, it's super brittle and it breaks for sample, set seed, stuff like that, which is super annoying. But like, if you have like 600 lines of complicated business logic, it's about all you can do, right? Like, what to make that a bit better. And then once you've like turned that into 50-line functions, you can like start writing tests for them, and then you can slowly kind of make it a bit better. Like, it's kind of
your old tests.
Yeah. You want to get rid of your characterization tests pretty quickly if you can, but they're a great crutch for when you can't do that. Okay. Well,
I think that's about it. Has anyone else got any comments or questions? Another thing for us to know, which I'm just going to put up. Sometimes it's possible to join this twice, and then you get this mad echo, and it happened to one of our speakers, because that's happened to me, and I'm like, what the hell is going on? Why is no one else commenting about this in the chat? But yeah, if you open it twice, there's this slight like half-second delay. So mad echo, so we'll have to remember to tell people at the start of the next talk.
Okay. Yeah. Well, to be fair, when we were testing this out, we broke that a couple of times because I was logged in at like 4 places at one point.
So, Flavia, do you want to jump back in? And I believe Flavia's here. Do you want to? Yes.
I am here.
Lurking in the background.
Yeah, I was just watching everything. So I just want to say thank you guys for everything. I'm just going to leave the newsletter link here in the chat box. And thank you, Richie. Thank you, Mick. Always a pleasure.
Yeah.
Thank you, everyone, for watching.
Thanks so much, Flavia. You did amazing work. Everyone should be very proud of Flavia. Wouldn't have happened without her.
We also have this tendency to break things on our 3 minutes before we're about to go live and have big adrenaline rush. So
The adrenaline.
Thanks for everything.
Thank you, guys. Hope you guys
enjoyed it. Everyone.
Bye-bye.
Bye-bye.
We'll see you next month.